Okay, hi, good afternoon everyone. Welcome to Menarini's webinar on hemoglobinopathy screening with the Hb9210 resolution. So just before we get going, some quick housekeeping rules. Please make sure your microphone is muted during the webinar. I think that's what I've done for you already. If not, try and keep it on mute just so there's no background noise so everybody can hear. If you do have any questions, hopefully there will be some questions. We'd like it to be interactive. Then at the end of the webinar, we will pick up these questions and answer them. And just one final thing, the session will be recorded. Everyone will get a copy of the recording after the webinar. Okay, so to introduce the Hb9210 resolution, it's sensible to introduce hemoglobinopathies, just as a recap. So following infancy, alpha and beta globin chains are components of normal human adult hemoglobin, and disorders of globin chain synthesis are termed hemoglobinopathies. There are over 1,000 globin chain mutations that can cause hemoglobinopathies. So on the left here in green, you can see this describes hemoglobin variants, and on the right here in blue, this describes thalassemias. So it's convenient to subcategorize hemoglobinopathies into two groups. So hemoglobin variants are structurally abnormal globin chains that reduce the quality of hemoglobin. Sorry, I'm getting a phone call there. Reduce the quality of the hemoglobin produced. So a common example of this would be hemoglobin S and sickle cell disease. Thalassemias, on the other hand, are results of gene abnormalities that cause a reduced rate of globin chain synthesis. So this reduces the quantity rather than the quality. A common example of this would be beta thalassemia, where there's a reduced rate of beta globin chain production. So just as a note, these two groups are not mutually exclusive. So you can have hemoglobin variants that also alter the rate of globin chain synthesis, for example, HbE, hemoglobin E, and we term these thalassemic hemoglobinopathies. Hemoglobinopathies have a varying degree of clinical impact for the patient. So as mentioned, there are over 1,000 mutations that can cause hemoglobinopathies. It's not possible or practical to detect all hemoglobinopathies, but we certainly must make every effort to detect those that are the most common and pose the biggest risk to quality of life, and that's at an individual patient management level and also at the family planning level. So therefore, we should detect at least the following: conditions where there's a reduced rate of beta globin chain synthesis and hemoglobin variants S, C, D, E, and O arrow. In the UK, as you're aware, there's a universal screening program for sickle cell disease through the newborn screening program. So sickle cell disease is one of 9 inherited conditions that are detected through the newborn screening program. Both sickle cell and thalassemia are screened for through the antenatal screening program. So it's worth noting that it could be that a patient presents with some kind of thalassemia that hasn't been detected through a screening program, as it could be with sickle cell disease, although, like I said, there is a newborn screening program for that. There is universal screening. So one of the screening methods used is a questionnaire, and it depends on the prevalence of hemoglobinopathies in a local area as to what the detection methods and the testing algorithm would be. This table here on your right doesn't describe that method to screen the questionnaire, but it does list high performance liquid chromatography. So I'm going to refer to that for the next for the rest of this presentation as HPLC. So HPLC can be used as a primary or secondary method to screen for hemoglobinopathies in the antenatal laboratory. according to Public Health England's recommendations. Menarini's HPL system is the HB9210 resolution, and this is the most advanced HPLC system on the market. The HB9210 resolution has full compliance with all of the recommendations outlined by Public Health England for sickle cell and thalassemia screening in the antenatal laboratory. Okay, so just going to introduce the HB9210 resolution with a few slides now. So the principle of analysis is ion exchange HPLC, high performance liquid chromatography. Simply this is where samples are injected onto an ion exchange column. Two mobile phases create a gradient difference in pH and salt concentration. Hemoglobin species have different physical properties. So, for example, surface charge, the hydrophobic and hydrophilic groups, and therefore elutes from the column at different rates. So this elution at different rates is detected by spectrophotometry through a detector at the wavelength of like 413. The dimensions of the HB9210, so this HPLC ion exchange HPLC system, is all contained within a neat small footprint. You can see the dimensions here. It's only 74 centimeters high, 54 wide, and 66 centimeters deep. So those dimensions also include the built-in CPU, and as you can see on the picture here on your right, you have a 15-inch high-definition colour display on an arm, so it doesn't affect any actual bench space and can.
How started the main thing? How started the...
Sorry, say that again. Was that a question or no? So the onboard sample capacity is 210 samples, which should be appropriate for most laboratories, but you have continuous load, and of course, if you have a significant workload, you can have multiple systems to manage any workload. Maintenance of the HB9210 resolution is, well, it says here minimum. It's a lot closer to none, actually. All of the maintenance is automated. You can schedule startup and priming of the system each day to fit the workflow of your laboratory. The daily maintenance is simply loading the reagents and consumables for that day, and the calibrators and quality control material. The reagents and all the consumables on board that need to run the system are all barcoded, so you have positive identification, which creates an ISO 15189 friendly audit trail that includes lot number, date that the item goes on board the system, and the expiry date. We mentioned before about the CPU. That's built into the HB9210 resolution. Analysis time. So there are two modes that the HB9210 can run in. It has a 4-minute quick scan mode and an 8-minute high resolution mode with that longer runtime for better separation. So the 4-minute quick scan separation, you can have an option to reflex the extended run program. So you can screen initially with the 4-minute quick scan, and then anything that you want that the system picks up as a no will reflex an 8-minute mode. So in the 4-minute quick scan mode, you have separate retention times and individual chromatographic profiles for HbA2, A2 variants, hemoglobins F, S, C, E, and D. If an unknown hemoglobin variant was detected in the 4-minute mode, you get an automatic reflex for that 8-minute high resolution. So, for example, hemoglobin variants such as HBO or HB Lepore, they would all be, you'd get better peak identification in the 8-minute mode, and the software would also auto-suggest an identification for these hemoglobin variants. So, we mentioned before, as part of the maintenance, you would load your calibrators and QC for that day. And what this means is having onboard calibrators and quality control material, you can have a quality control program that fits exactly what your local quality management system dictates, what you need for statistical process control based on risk and how many samples you want to run and what levels of QC you want to run and when you want to run them. So the system is designed with complete walkaway time in mind. Regardless of whether you use third-party quality control material or manufacturer quality control material, you have quality control management. And you can see here in the bottom left of this slide, you have a Levi Jennings chart, a run chart, where the QC data's plot, where you can see QC data. The ranges can be defined by the laboratory, and obviously that allows you to review your QC data over time to ensure that you've got best patient results. Okay, so superior separation. Exclusively on the Hb9210 resolution, there is the use of the position marker. So I'm going to explain a little bit about this position marker, and I think Lisa's going to touch on the position marker also, so I'm not going to spend too much time on it. But this position marker allows for best accuracy and standardization. And the way this is achieved is the retention times of hemoglobin F, A, S, and C are reassessed every 20 samples, and that's an automatic injection of this position marker. That's because regardless of what chromatography system you use, you're going to have a tiny amount of drift, and also all the other things that you will be aware of that account for uncertainty of measurement are mitigated somewhat with this position marker. So this relative retention time is set, and each patient sample is compared to these relative retention times. So you're going to get the same consistent results regardless of column, environmental, the environment the sample's being run in, or no matter which users operate in the system. All of this helps to produce a very precise system with a typical precision of less than 2%. And again, that's something Lisa's going to touch on in her presentation. Another nice feature of the system is that we mentioned before there is an auto suggestion of typical chromatographic profiles. So you can see here in this result in the sample window to the left, you have this is the main assay window, and the patient samples traces in red, and this green trace is the overlay feature. So the system, depends on the complexity of the hemoglobinopathy being considered, might offer 1, maybe 2, 3 suggestions, and the user can then overlay these typical chromatograms to ensure that what their intuition matches what the system suggests. So this result overlay perfectly complements the analytical accuracy of the Hb9210 resolution, especially when you consider one last feature I'm going to tell you about, which is the onboard reference library or variant library. So the Hb9210 resolution is a dedicated and specialized HPLC system for hemoglobinopathy screening. So the built-in software has an extensive reference library for chromatogram comparison and suggestive results analysis. So this variant library has typical chromatograms, and it shows you how they will appear exactly on the Hb9210. Each of these variants has been confirmed by DNA analysis, and it's constantly being expanded. At the moment, there are over 150 hemoglobinopathies described within this variant library. So I've got a few slides here that show you the type of thing you will see in this variant library. So not only do you get the HPLC trace exactly as you would see it if it was typical, of course, on the Hb9210 resolution, along with the retention times and the peak identifications that are labeled here, you get to see the clinical presentation in the heterozygote and the homozygote, and also what the chain is that causes the hemoglobinopathy, what the likely ethnicity is, and some extra information also. At the bottom here, I'm just going to quickly flick to another one so you can see kind of a few different ones. At the bottom here, you have comparative results. So you don't just get results, what the likely output would be on HPLC on the Hb9210. You also get what it would be on electrophoresis, isoelectric focusing, And as we mentioned before, as the PHE recommend multiple methods to screen for hemoglobinopathies, that's a really neat tool for the experienced user as a sense check, and also as a training and learning tool for the less experienced biomedical scientist or consultant. So I'm going to hand over to Lisa now. If people are interested in this variant library, reach out to us, let us know. We can certainly get copies of the reference library out to you. I just want to summarize and go over the headlines from that brief presentation I gave them. So the HB9210 resolution is fully compliant with the UK screening recommendations set by Public Health England for the antenatal laboratory screening for hemoglobinopathies. It has an exclusive position marker for best standardization and the most accurate HPLC measurement. The chromatogram overlay feature, combined with the extensive reference library, aids training and validation. All of this in an easy to use system with minimal and next to no maintenance. Okay, thank you. So if there are any questions, as I mentioned at the beginning of this presentation, please put them in the chat box. I'm now going to hand over to the main event, which is Lisa, and she's going to talk to you about her experience with the HB9210. So I'm sure you're all familiar with Lisa, but I'll introduce her anyway. So Lisa Farrer has a wealth of experience for newborn and antenatal screening, hemoglobinopathy screening. She's the laboratory lead at Leeds Teaching Hospitals, and I'm really looking forward to hearing her presentation. So I'm going to stop sharing my screen now and hand over to Lisa.
Thank you. And I'll try and share mine seamlessly.
That's the illusion.
Okay, let's see if this works. Okay, is that working? Hopefully. Yeah. Okay. Yep, that's okay. Right then. Good afternoon. I'm delighted to be invited to speak to everyone today and give you an overview of our evaluation of the 9210 resolution, and mostly the reasons for choosing that analyzer as our HPL system of choice. To do this, I first really have to go through a very short geography and history lesson, so hopefully you can bear with me. So let's start with the geography. The Leeds Teaching Hospitals NHS Trust consists of 5 hospital sites, the largest of which is St James's University Hospital and Regional Cancer Unit. Hemoglobinopathy diagnostic testing is performed in the Yorkshire Regional Newborn Screening and the Leeds Antenatal Sickle and Thalassemia Screening Laboratory at St James's. It's a combined multidisciplinary screening lab with a client population that is a very diverse ethnic background. We screen roughly 45,000 babies and 36,000 adult antenatal patients, referred samples for diagnostic work, or monitoring samples for sickle cell disease patients that are undergoing exchange transfusion. And the laboratory is also a The laboratory is also a referral laboratory for other regional laboratories for differential diagnosis of hemoglobinopathies and thalassemia. So that's the geography, and now to the bit of the history. I took responsibility of the screening laboratory in 1994, and at that time it was a relatively small section doing mostly manual analysis and testing approximately 20 samples a day and roughly 30 to 40 hemoglobin A2 and F estimations a week. Over the workload gradually increased over the next 4 to 5 years, and in 1998, it became evident that there was a need to introduce automation into the laboratory. Our workload had increased, and in order to help reduce the strain on the staff trying to multitask with the increasing workload, we also wanted to reduce the risk of reporting analysis errors, which were due to the lack of positive patient identification running throughout the whole process, and remove the manual validation and result entry. We were relatively new and a novice to the field of HPLC, and we decided at the time on the market leader. It was small, it was compact, and it was automated, so hopefully it did what we wanted it to do. But in 2000, we were asked to look at the Primus Ultra system, HPLC system. And this was because it was being utilised on one of the other Leeds sites to perform HbA1c monitoring. So our first impressions of the Primus was it was large, it was clunky, and it had a huge footprint. We were very sceptical that it could replace our small petite analyzer that was working fine in the laboratory. However, second impressions, we found that behind the rather outdated appearance, there was an outstanding analyzer. It had low maintenance, it had excellent accuracy and precision. It had 3 run modes for better resolution of the abnormal variants and differential diagnosis. And it was our first introduction to relative retention times, which revolutionized the way we looked at hemoglobinopathy analysis. And it enabled us to produce a library of abnormal variants because the relative retention time was stable between reagents, columns, and even sites that had the same analyzer. And it was ultimately very user-friendly, even if it was clunky. So we changed to the Primus Ultra 2. This wasn't without its problems and its issues, and mainly these issues for us were supplier issues. So over the time that we've had the analyzer, there has been approximately 7 to 8 supplier changes for this instrument. So most people would say, why did we persevere? But basically, the instrument outweighed the problems, and it wasn't worth us relinquishing the instrument because of the problems, and we stuck with it through thick and thin. So obviously over the years things have changed, and we've been asked to look at various different hemoglobinopathy solutions over the last 3 decades. And this has been from all of the market leaders, but for us, none of those analyzers have really offered the same resolution, reliability, user-friendliness, or the unique features of relative retention times that the Hb92 resolution has done for us. We even have had options of loading and walking away facilities, but this wasn't sufficient for us to warrant compromising the resolution of the assay. So with regards to the changes in our laboratory, we've gone from a small volume working and testing site to testing 45,000 babies and 36,000 adults. And this has had a massive impact and change on the workload, which has resulted in different demands on the performance of the analyzer that we've needed. So HPLC is currently our primary technique for antenatal screening. The HPLC needed to be rapid, reliable, accurate and precise in order for us to maintain the Public Health England national standard for turnaround times of 3 working days. HPLC is our secondary technique for newborn screening, with tandem aspect being our frontline technique, but this also brought with it a lot of new challenges for the HPLC systems of choice in the lab. We needed to have the ability to identify hemoglobin S and other significant variants at very low percentages of less than 5%. We needed good resolution of fetal hemoglobin, adult hemoglobin, and hemoglobin variants S, C, D Punjab, E, and O Arab. And we needed to be able to differentiate at very low levels of hemoglobin A. This was in order to help us identify babies with beta thal major as opposed to very premature babies. So again, why did we choose the 9210 resolution as our evaluation of choice for HPLC analyzers? Firstly, our Primus Ultra is now out of production and it's been withdrawn from service. So we needed to have we're in a relatively urgent position to replace and change our technology. We needed a replacement solution that maintained the resolution we were familiar with. In addition, we had to have additional features that would bring us into the 21st century and away from our favourite clunky analyzer. So first impressions of the Hb9210 resolution. It's smaller, it's a sexier HPLC analyzer with all the features of a Primus Ultra 2. But it was fully automated with continual loading and walk-away facility. The system was familiar to the staff. It was a Primus in a small package, so it has aided in the training and ongoing training of new staff on the analyzer. We have still got the 3 running modes, the quick scan and the high res running mode, but now instead of the 10-minute high resolution run on the Primus Ultra, we've got a shorter 8-minute resolution. And also we've still got the quick scan and reflex for better abnormal identification and faster running through of normal patients in the quick scan mode. Relative retention times have remained with this analyzer, and this is one of the major points for us actually wanting to look at this HPLC analyzer in the first place, because relative retention times have revolutionized some of the ways of us looking at abnormal variants. It's easier maintenance than a Primus Ultra, and we didn't think that that would be possible because the Primus Ultra is really good, but this has a lot more ease of maintenance and a lot more automated processes, as Jake has already outlined. The accuracy and precision is better than the Primus Ultra, but that is now a very old kit, over 20 years old. So what are the new features that we like about this analyzer? The random access continual feeding is a bonus for us to be able to continually feed samples through the processing part of the analyzer. We can now get 2 Hb9210 analyzers in the footprint of 1 Primus Ultra. And the IQC onboard monitoring and onboard reagent management has made this an ideal analyzer of choice for us. So basically, we started our journey with the Hb9210 resolution back in 2017. It was marketed for distribution at this time, and the analyzer was an excellent analyzer. We started the evaluation, but we gradually ran into some issues which arose with the resolution and the composition of the columns and column life. The column structure was altered and a pre-filter was put in, and a couple of software updates happened. The analyzer was at this point adequate for screening for both newborn and antenatal samples, and following this part of the evaluation, the analyzer lay dormant in our lab for 3 years. So in 2020, we were notified of a major revamp for the column composition and build structure. In addition to this, there was also a major software upgrade. So during the COVID lockdown and times when we had some time on our hands to be able to do another evaluation, we did our final look at the Hb9210 resolution and the upgraded column and software system. But this time we had to start looking at the whole system with a view to replacing the current in-house analyzers, as these were nearing their end of life. So what changed in that time scale of 3 years? The system and the new column upgrade had stabilized the whole process. The column was improved and it had improved reliability. There was excellent resolution and retention times, and it was equally as good, if not better, than the Primus Ultra. So sorry about the next slide, some of them are very busy, but I'm just going to go over some of the performance that we got with the analyzer and the evaluation. So if we looked at the IQC values obtained over 6 days, we could determine the IQC interassay CV performance for the analyzer. So looking at the comparison between both of the evaluations in 2017 and now, we found the CV for both evaluations were good, with the highest CV of 4.74 for hemoglobin S, followed by F at 1.73 and A2 at 1.62. It is generally considered that an interassay CV of less than 15% is generally considered acceptable. So the analyzer passed the first step in the critical performance criteria analysis we were doing on it. We also looked at the CV on our current analyzers' uncertainty of measurement performance to see if there was any difference in the two systems. We found from this and identified that the CVs were comparable for hemoglobin A2, but the 9210 had a far more improved CV performance for hemoglobin F than our current analyzer. The next thing that we looked at in our critical assay of performance was to look at the IQC interassay CV performance. And this we measured in duplicate 36 level 1 and level 2 IQC samples and 18 HBS IQC samples. as the IQC for HBS is only in level 2, so we could only run it 18 times. All the intrassay CVs were acceptable, and again, it passed the second layer of critical analysis for the analyzer. With any analyzer or HPLC system that you employ within a laboratory, the EQA performance of that system is an essential part of both your UCAS accreditation and also the lab's performance. So we had identified previously that we were having some problems with our Primus Ultra because the actual EQA performance compared to the market leaders at the time, we were showing some bias and were having some performance issues with the Primus. So at that time, we've changed our criteria by looking at both NEQAS EQA schemes and also the College of American Pathologists EQA schemes. This was to satisfy our concerns that we didn't have an actual analyzer problem. So by doing the NEQAS EQA, we could identify that we had a problem that was out of consensus with the current UK analyzers that were being distributed. But by putting ourselves into a larger pool of Primus users in the US, we could see that the analyzer was performing within the correct criteria. So we actually allayed the problems that we had with that. But looking at the EQA performance for the evaluation, there were no poor performances over the EQA schemes tested, which is always a big relief to the lab. And the results from both the Primus and the 9210 were excellent against the desired values, which you can see in red. And I hope these slides are clear for you. So we were quite happy with the EQA performance for both the Primus and the 9210. Another area that's very important is to look at both your normal sample population and your disease population. So basically, we evaluated and identified 143 normal patients with normal levels of A2. And this was where we started to see that we had an overall positive bias of 10% for normal A2 levels of less than 3%. And we also had an overall negative bias of 15% for the beta thalassemia patients and borderline hemoglobin A2s greater than 3% up to the 3.5 and above A2 percentages. So the 9210 was found to have an overall higher A2 within the normal A2 range and the overall lower A2 within the beta and an overall lower A2 within the beta thalassemia range. So the negative bias that was noted over previous NEQAS EQA schemes that we've found for the Primus, we found that the current instrument, particularly at low levels of A2, were within the required A2 region for the EQA values. So the positive bias that we were seeing on the Hb9210 in this instant corrected the issues and problems that we were having on our EQA schemes and brought us back into line with everybody else and consensus with all other users. So it gave us a lot more confidence in this analyzer moving forward, and if it was the analyzer of choice for us to move to. The critical cutoff for hemoglobin A2 is 3.5%, and this is outlined in the Sickle and Thalassemia Antenatal Laboratory Handbook. There is a grey area or a borderline area between the top of the normal range of 3 and the bottom just below the cutoff of 3.5. And in this area, you can get some of the rarer silent A2 beta thals and some more equivocal results which require a lot more closer scrutiny. So we wanted to check that the results that we were getting both from the earlier evaluation and this evaluation gave us consistent results that would ensure that the critical cutoffs were met. On comparison of the results from 2017 to current date ones, we found it was clear that there had been an improvement in the comparability of the results in the critical region, and with none of the patients that we had were resulting in misdiagnosis or a missing beta thal carrier diagnosis. We also decided it was important to look at the performance of beta thalassemia for the analyzer by looking at the NIBS standard reference material. And this is an A2 reference material that can be used to test the analyzer either post service or when you have a problem or issue with your analyzer at any time. The performance of the analyzer results were very comparable and gave us excellent precision for this analyzer. Looking at the A2 comparison for the Primus and for the Hb9210, we saw that there was good comparison between the Primus in the beta thal ranges. So we were more than happy with the critical area of testing. So what are the advantages and unique features of the 9210 resolution that makes us want to have this as our analyzer of choice? The first one, as Jake has already mentioned, is relative retention times. The FASC position marker sets the relative retention time for each peak. So we already know that we're looking for the significant hemoglobins of S, C, D, E, O, Arab, and we in the laboratory already know what specific retention times are aligned with these hemoglobin variants. An F, an A, an S and a C, you would get a relative retention time of 1 to the respective marker in the FASC control. With hemoglobin D Punjab, it runs in the S position, and it usually gives us a relative retention time of between 0.91 to 94 to S. So a distinctive difference to where the S would run. Similarly, O Arab runs 0.91 to 0.94 to the C in the FASC. So we can use this quite specifically when we're looking at our populations of samples, but obviously there's hundreds and thousands of samples that could run variants that could run in these positions. So it's only a use to help us determine the phenotypic makeup of the patient before we go on and do differential diagnosis with isoelectric focusing and tandem mass spectrometry. A unique feature of the 9210 that isn't available on the very outdated software that I have on the Primus is the abnormal results overlay. Because the library consists of differentially diagnosed variants that have been identified by DNA analysis, you can be confident that when you're overlaying those chromatograms over the top of the patient chromatograms, that you've got a true positive patient identification or positive abnormality confirmation, that you're not going against something that could be a C or could be a G Philadelphia. So it gives you some confidence, and it will help in training new members of staff in understanding the chromatograms and understanding the differences in the positioning of various variants. Again, the 3 running modes is a unique advantage, and for the main large workflow laboratory, the quick scan with reflex is an ideal opportunity to run through all your normal variants at a rapid rate of knots, and then follow that up by reflex in the abnormals to get that superior definition and variant identification. Precision and sensitivity. It has an ability to positively identify hemoglobin variants in very, very small percentages. In the newborn screening side of my laboratory, newborn blood spots, we need to have the sensitivity of the analyzer, as this is an essential requirement and to enable us to pick up minute amounts of hemoglobins. We also have improved identification of hemoglobin A2 variants and A2 prime, and also a better resolution to give us more appropriate hemoglobin A2 percentages at low levels. So the next few slides are just some examples that I'm going to run through of patients that we have that hopefully will show you how precise and accurate some of the results are, and also the sensitivity at very low levels of hemoglobin variants. I apologise if these are quite faint, because the Primus ones on the right hand side are a lot fainter than the 9210s on the left. So for newborn screening, it's essential requirement for the laboratory to be able to pick up hemoglobins S, C, D Punjab, E and O Arab. We also have to be able to identify these variants down to very low percentages, because that will help us determine any further actions or clinical referral for the patients. So the next couple of examples will show you some of these, highlight some of these specific points for the analyzer. So in this example that you see here, we've got a patient that's got hemoglobin F, acetylated hemoglobin F, an A peak and a peak which runs in the S window or S position at 0.9952 S, which to me is a 99.9% surety that it will be hemoglobin S. So we can identify the same peak in the Primus Ultra 2, which runs at the same position as the peak that's identified in the 9210 resolution scan. The uniqueness of this analyzer is the fact that we're looking at here at a percentage of 2.4 to 2.6%, and that resolution and that sensitivity I haven't been able to pick up in many other analyzers that I've evaluated over the last few decades. In this second example, it's just another example of a carrier hemoglobin. Again, we have fetal hemoglobin, acetylated fetal hemoglobin, because wherever you have large quantities of F, 10% of that will make up as acetylated hemoglobin. We've got hemoglobin A, and then we've got hemoglobin C. And in this case, it's in the C position at 0.994 to C, which again, 99.9% sure that it would be a hemoglobin C, and I'd be happy with that diagnostic result. And it also gives me the indication on where to go phenotypically if I'm going for differential diagnosis and doing isoelectric focusing and tandem mass spec. So while looking at babies, and as I've already mentioned, the major aim of newborn screening is to identify babies with sickle cell anemia and to get them in a timely manner and referring them into critical care or clinical care within 90 days in order them to be on prophylactic penicillin. In addition to sickle cell and thalassemia, sickle cell disease, thalassemia is another byproduct of the screening process, and beta thalassemia major or intermedia has become one of the other clinical cases that needs to be referred into clinical care. So we need to have the ability with any screening or second line screening method to be able to identify very low quantities of hemoglobin A in a patient, because that could determine that they have beta thalassemia intermedia, but also be able to identify hemoglobin A percentages at very low levels, because we have a lot of premature babies in the 20-26 week region. So the next two examples that I'm showing you here are from 26-week gestation babies. Again, the Primus Ultra is on the right-hand side, the 9210 is on the left-hand side, and we can clearly see there is a peak identified in both of them, which is in the hemoglobin A position. However, there is no identification marker for the 9210. It only managed to pick up the fetal hemoglobin. So initially, this was a slight concern to us that we would be not able to identify low levels of A in premature babies. But if the same problem occurred with the Primus Ultra, we'd do the same thing as we did with this case. We increased the number of blood spots that we used from 4 to 5. And on the next full quantitation, we found that the analyzer was able to quantitate this hemoglobin peak at 4.5% in line with the Primus Ultra. The second baby is another 26-week baby. Again, this time you can see that the hemoglobin A peak has an identifier on it, and it's been able to identify this as a 4.3% hemoglobin A. So we can determine that this patient does not have beta thalassemia or beta thalassemia intermedia. By comparison, I'll show you a few slides of patients with significant disorders or positive cases. So this is an example of a baby with beta thalassemia major, where only hemoglobin F is present and hemoglobin A is completely absent in both of the scans. By looking at both of these chromatograms, you can see that the resolution for both of them is very, very good. We're getting a lot better separation on the 9210. It's clearer than on the Primus, and we're seeing all the abnormal peaks that the chromatography is picking up. We can't go without showing a couple of examples of sickle cell and sickle cell disease. So this is from a baby with sickle cell anemia, and again the sickle hemoglobin is present, and because they've got sickle cell disease, they have no adult hemoglobin present in the screen. Similarly, a baby with hemoglobin SC disease, and again we've got S present, C present, and no adult hemoglobin. And by looking at the relative retention times, in this case, C is 0.996 to C and S is 0.997 to S. So it's a very good diagnostic marker of SC disease. So that's the newborn screening side of things. The other area that I said that the 9210 was good with was low levels of hemoglobin A2 and variant A2 or A2 prime. So I've got two examples that show this. The first one identifies a patient with very low hemoglobin A2. And this is where I said that we already had a negative bias on our EQA schemes because the Primus was underestimating hemoglobin A2 levels. So this is the quick scan mode, and by looking at the resolution of the A2 from the large hemoglobin A peak, you can see that some of the A2 percentage could be lost by this lack of resolution. We ran that on the high resolution scan, and again the separation was better and the resolution was better, so it increased to 1.4%, but it still wasn't an adequate resolution or quantification. The same sample run on the Hb9210 gave much better separation, a lot of resolution of the A2 from the hemoglobin A, and this is where this was a superior separation to the Primus at these very low levels, and it gave us an adequate hemoglobin A2 of 2%. So moving on to look at the A2 prime, this is a further area where the 9210 has proven to match and exceed the performance of the Primus in his measurement of the A2 primes or A2 variants. So again, the quick scan on the Primus identified two peaks, but was only able to quantitate one of those peaks because the second one wasn't resolved from the hemoglobin A peak. When these were run then on high resolution scan, both of the peaks were fully resolved and we were able to quantitate both of the hemoglobin percentages. The superior part for the Hb9210 is the fact that this whole process was done in a 4-minute program for the 9210. It was able to identify both of the peaks. It was able to quantitate both of those peaks in order for us to be able to make an A2 quantitation of 3.3% within a 4-minute program rather than 14 minutes, because we would have had to reflex it on the Primus. So it shows much more superior quantitation abilities to the Primus Ultra. So I'm going to finish with an interesting, hopefully you find an interesting case, and this is a newborn case, but it really goes to show how the 9210 has superior qualities to our current analyzer. So with tandem mass spectrometry, which is our primary technique for newborn screening quantification, we identify and look for just the portions of the globin chain where hemoglobins S, C, D, E and O Arab occur. And we look for a higher signal if these occur in the patients. So this patient here has no signal for S, no signal for C, a high signal for D, no signal for E and no signal for O Arab. So the points to consider is that we've got a high ratio of hemoglobin D Punjab in this patient. So we need to go on and do secondary testing by HPLC. We have a peak that is 0.91 to S of 2.5%, and this would indicate that this was probably a hemoglobin D Punjab to us. The only thing that was spurious to us is the large peak between the F and the hemoglobin A that really shouldn't be present in a beta chain abnormality such as D Punjab. The problem that we have with this diagnosis as a Primus user is we have a peak in a D position, we have a tandem mass spec result that tells us there should be some D there. So how do we report this? Do we report it as a D, follow the patient up and see whether it actually turns into a D, or do we have to do further diagnostic work? So just as an example to show you the difference between a beta chain carrier and this abnormality, is we've got, this is a sickle carrier in this case. So we've got the F peak, acetylated F, A and D, oh sorry, S. And in this patient, we've got the F, the acetylated F, the A, the D query, and this abnormal peak between F and A. So what we're going to look at now is a comparison between the 9210's peak that we're seeing here at 0.91 to S, that I would think was a D, and the one that we see on the 9210, which is 0.99 to A2, which clearly identifies it as a hemoglobin E if it was there. So you can see there's a difference between the two analyzers here. But the 9210 now helps us make a differential diagnosis. We know that that peak isn't E because we know that that peak isn't D because it's running in the E position. We now have to determine what this abnormal peak is that's between F and A. So if a patient's got a beta chain abnormality, you only see 3 abnormal peaks: the F, the A, and the S, the D, the C, or the O Arab. If a patient has an alpha chain abnormality, you see the F, the acetylated F, a hybrid variant, the A, and the variant that you're seeing. So what we're actually seeing in this patient is an alpha chain variant. It is not hemoglobin D Punjab, and the peak that we're seeing that is so large between the F and the A is actually a combination of abnormal variant and fetal hemoglobin that forms a hybrid and identifies this as a non-significant hemoglobin variant. So the 9210 in this case helped us make a differentiation between what we thought was a D and what we actually now can confirm is an alpha chain and non-significant disease state. And one of the main reasons that this makes this analyzer our analyzer of choice going forward. Thank you for listening. That's my presentation over, and hope if you have any questions, you can share them with me. And I'll stop sharing now.
Thank you so much, Lisa. That was really interesting. I'm sure everyone will agree. That was amazing. Thank you.
No
so there's just one question in the chat box from Chris Lambert. I'll read it out and grab an answer. So do some centres run on high resolution scan for all samples? If you see a lot of variants and reflex them, if you reflex them all, that could take longer than, say, the Biorad 6-minute scan. Yeah, so with the Hb9210, there's 3 modes you can run in, and you can choose which of the 3 options you run in. So, and it would depend obviously on your propensity to detect hemoglobinopathies. By that I mean what your prevalence in your area is. So if you had a low prevalence, perhaps you would just run the 4-minute scanning, wouldn't reflex at all, maybe, and it depends on your workload as well. So the system's very flexible in that way. So yeah, I mean, if you had an unknown variant, I would want to have that longest run time so you get the best result at the end of it. So you are adding a little bit of extra time, but you've got the best separation with the Hb9210 to make the best clinical decision, I would say. Does that answer the question?
I was going to say, do you want me to answer from sort of the lab's perspective?
Yeah, definitely. Yeah, please.
Yeah. I mean, we have currently 2 primacies and hoping to replace them with 2 9210s. So all of our newborn screening, second line screening, will be going on to 1 9210, which is running high resolution mode because that's the best resolution for us to use. The other one will be continuously moving. At the moment, we think on quick scan with reflex, but technically if we've got 2 analyzers side by side, we could do quick scan through for all of the samples, and then anything that's would reflex for an abnormal, put it onto the newborn screening analyzer and put them as a 10-minute program on there. So you're utilizing them, both instruments, at the maximum capacity, really.
Thank you, Lisa. Thanks for the presentation as well. So that was good. I mean, I think I was typing that in just as you got to that bit about switching between quick mode and reflex mode. So that was quite timely. I just wanted to get a feel for what you would do in a practical situation. So it's interesting to hear that you'd use that high res mode for all of them, because that would almost be my temptation to do that as well, because to a certain extent, time with hemoglobinopathies, you know, you tend to load up the machine and walk away and let it run. So does it make a difference, really? No.
No.
Thank you.
No problem.
Okay, so there's a question here. How often do you run the nib standard? I think that's one perhaps for you, Lisa.
Yeah, sure. I mean, obviously, currently we run it with the evaluation, but I think if ever you've got any serious problems where you're looking at IQC failures, poor performance issues, analyzer issues, or even post analyzer breakdowns, using the nib standard is always a good line to actually check that you've got your A2 values back within the lines that you want, and it is something that we'll be using on a regular basis. I think the other thing that UCAS have brought up for us is that we have to do comparisons of our two analyzers on a 6-monthly basis, and that again would be a time when we'd use the nib standard to compare both analyzers and check that they were comparable and working within the right specifications.
Okay, thank you, Lisa. Is there any further questions? I mean, we've finished the presentations. We've got 1 or 2 minutes now. If anyone wants to shout out, you don't have to put it in the chat box.
Hi, Jake. Ishmael speaking.
Hi, Ishmael.
You mentioned in the presentation that it's 150 DNA verified variants in the onboard library. Is it 150 or is there more?
There's more. Sorry, I should have said more. I think I did say more. Perhaps I didn't. But yeah, it's over. It's over 150.
Yeah, and I also spoke to Trinity when they came to take away our Primus, and they're more than happy that if we identify any new ones that are on that library, that we can forward samples to them for DNA analysis and differential diagnosis, and they could be added at sequenced events, you know, software upgrades later. So that's something that can be built on. It's just not a fixed library, and that's the end of it.
Thank you.
Stitching me up for an exact number there. It's one of my colleagues. Okay, there's a question for Daniel Horrich from Daniel Horrich. Has the 4-minute mode ever missed a variant?
I can honestly say that the 4-minute mode has probably picked up more variants than we would have expected, because it's extremely sensitive, and sometimes when you're quickly scanning through the scans, it can actually split A peaks and find variants that we wouldn't have seen. So it doesn't generally miss them, but the ones that it has missed in the past, because it has missed a few of them, would be ones that would be probably silent variants that will sit under the adult hemoglobin. It's not missed any that have moved away from the hemoglobin A. So there tend to be ones that have been sent to us from the A1C measurement. They use the TOSO for A1C, and that picks up a lot of different variants than the 9210 does, which is basically silent on our analyzer.
Okay, so are there any other questions? If feel free to shout out now. If not, then
I've got one question.
No.
What's everybody's opinion about the current NEQAS A2? Because it seems to bias it against the bigger users, and obviously we're in group here, all right, and we've had a similar problem to you, Lisa, that we're a TOSO user, that we seem to have a negative bias A2 compared to like Biorad, so to speak.
Yeah.
But obviously because the group everybody's an overall mean.
That was
from UCAS perspective, you have to do a non-conformance because your DI covers above 2, but within group you're not. But
yeah, with our performance, we were slowly seeing ourselves going out of performance with the hemoglobin A2, which was the main reason, well, one of the main reasons why we took on the American College of Pathologists EQA scheme. The other reason we took it on is it does a dry lab challenge, which is absolutely excellent for training purposes for the lab. So we use it more now for that than we do for the other. But it was basically, instead of us being in a small group of Primus users where we were slowly getting concerned that it wasn't working well, we were then put into a group of 60 to 70 plus Primus users, and we will find we were quite within the consensus of that group. So that adequately allayed any fears for UCAS, and they were quite happy with that. Plus they were equally more happy with the American College of Pathologists because of the dry lab challenges and the training facility it was given for the laboratory staff as well.
Just another question, Liz, what's the cost of that NIBSAC standard, and is it easy to get hold of? Because most of the
you can just order it.
Is it
expensive?
I
don't know what is. I don't think so. I can't remember, but I can send it on to. I'll let you know. I've got the
I'm going to
pricing
say
at home.
for us, obviously we're going out for tenders shortly.
Yeah.
Obviously, it'd be nice to, because I have done that with Factor 8s before on another site. I've told them to get the NIBSAC standard, so that at least you've got reference material that you're more confident in this, so to speak.
Yeah. Yeah. No, I don't. It wasn't that expensive. It's not a huge amount, but I can't remember off the top of my head how much it is.
I'll inquire.
It's been a while since.
Can you send me some details? Send me some details.
Yes. Yeah. I can send you details.
I think Jake's got my email. If you pass my email on to Lisa, Jake, and then
yeah. And I think somebody's also asked in the chat, do we pick up recartons? And the answer to that is no, we don't pick up recarton at all.
Lucky.
Yeah, because we get that a lot of the query recartons referred to us from our A1C friends at the LGI, and we can't see the recartons at all. They're totally silent.
The thing that I'd add to that as well, if it's picked up in a diabetic screen when you're testing for HbA1c, there is some ethically grey ground between that referral, perhaps. How most of them are detected with a Tozo machine, and every single system, and that's why the screening methods, you have to have multiple systems. Each one's got their own nuances. With electrophoresis, you're going to miss it. It's the nature of the beast. So that's, we kind of have to have a holistic and open mind about what we're detecting here.
Yeah.
Okay. If there's no other questions, I'm going to end the. Oh. Having hate with Necras. Yeah, so
yeah.
Everyone's having that Necras problem, not just small users. I think everyone must be doing NCs or Kappas for every Necras.
We've got better then, because we've got out of that now, finally.
Oh, okay.
Finally.
Okay, thank you so much for listening and attending. I know there were some people that couldn't make it based on the registration list and who attended. We'll be sharing the video with a recording of the presentation and the question and answers with everyone. Feel free to share it with your colleagues as well. The sales team and myself are there from Menarini's side to pick up any other questions or any other issues. I'm sure Lisa, I'm going to say, won't mind fielding any other questions outside of this as well. But yeah, thank you for your time, everyone. I know you're all busy, and yeah, thank you. See you later.
Thank you.
Bye-bye all. Thank you.
Bye-bye.
Bye.
Thanks, Jake.